Okay, so now you have learned how to find missing sides of right triangles using SOHCAHTOA, right? Here's the thing. Sometimes we have triangles that show up over and over and over again. Instead of solving for the sides, we can give like fixed ratios to help you solve for them easier, okay? We have two types of triangles that constantly show up. One of them is a 45, 45, 90 triangle, okay? That's one of the special triangles. And the other special triangle is 30, 60, 90 triangle, okay? So these triangles show up a lot in math, and it's gonna come into importance in the next few lessons. But what we're gonna spend time doing is really just understanding these triangles and where we get these little shortcuts from, okay? So in the 45, 45, 90 triangle, let's say we make the hypotenuse x. We can now solve for the other missing sides using Pythagorean theorem, right? So I'm going to write a squared plus b squared equals c squared. As we know, the c is always the hypotenuse, and then we have our two sides. Now, because this is a 45, 45, 90 triangle, these two sides are actually congruent. They're the same length, meaning if one of the sides is 10, then the other side is 10. Right? So instead of labeling them A and B, I'm just going to label both of them A, right? Because they're the same length, right? A is the same as B in this case, okay? So I'm going to write out my Pythagorean theorem. So I have A squared, that's one of my legs. The other leg is also A squared equals, and now my C is X, so X squared, okay? I am now going to solve for A. Okay, so I can combine these, and these will give me 2a squared equals x squared. I'm trying to get a by itself, so I'm going to divide both sides by 2. So I have a squared equals x squared over 2. And then lastly, I don't want the square, right? So I'm going to square root both sides. Okay, so I'm left with a equals, and then square root of x squared is just x. And then at the bottom, square root of 2. Right? Here's the thing. We generally really do not like square roots on the bottom. So what we're going to do is we're going to do something called rationalizing the denominator. What that means is we're going to multiply the top and bottom by square root of 2. Okay? This is just 1, right? So this is why it's possible. So what happens is if you multiply, x times square root of 2 is just x squared root of 2. And then square root of 2 times square root of 2 is just 2. So this is what A equals, okay? So what that means is these sides are x squared root of 2 over 2, x squared root of 2 over 2, okay? It doesn't look that pretty, but basically this is a little shortcut, and it'll make sense in a second, okay? So for the 30, 60, 90 triangle, to truly understand it, what we're gonna do is I'm gonna actually draw another 30, 60, 90 triangle. So I'm gonna make it dotted like this, okay? Oh, that was not good. Okay, so this is 60 degrees. This is another 30-degree angle. So this is actually 60 degrees. So what happens is this is now an equilateral triangle, right? All the sides are the same. So if I make this x, that means this side is x. That means this whole side is x, which means this part right here, this is just half of the side. So this is just 1/2 x. Okay, so now that we have these two sides, we have the x and the 1/2 x, I am going to solve for this missing side right here using Pythagorean theorem, okay? So again, I'm going to label my sides. My hypotenuse is C. I want to make this A and make this B, okay? So again, I have a squared plus b squared equals c squared. So I don't know what A is. I know B is 1/2 x. And I know C is x. So I have this. So when I solve, I know there's not a lot of space, but I'm going to have a squared plus 1/4 x squared equals x squared. Remember, there's an invisible 1 here. I'm trying to get a by itself, so I'm going to minus by 1/4 x squared on both sides. It's getting a little messy. I'm going to have a squared equals, if you do 1 minus 1/4 in your calculator, you're going to get 3/4 x squared. Last step, I'm going to square root. So a is equal to, well, okay, here's the thing. we can take the square root of each part. So square root of 3 stays the same. Square root of x squared is just x, and square root of 4 is actually 2. So it can be simplified to this. So what that means is this side is actually just x square root of 3 over 2. So if it makes your life a little bit easier for the 30, 60, 90 triangle, you can redraw it, because I know it's kind of intense. There's a lot of work. So this was x, this was 1/2 x, and this was x square root of 3 over 2. Okay? So this was all just explanation, kind of just explaining where we got these, what we call these are basically like little shortcuts. They're little ratios. What we're going to do now is we're actually going to use them. And it's actually very, very simple. Okay? So what we're going to do is we're going to solve for these missing sides. Okay? So you could totally use Pythagorean theorem, right? But it might take a little bit longer than just using the shortcuts. So this is a 45, 45, 90 triangle, right? So I know that these are the shortcuts I'm going to use from the first triangle. According to my shortcuts, this is x squared root of 2 over 2, and this is x squared root of 2 over 2. But look, I know now what x equals. X is equal to 4. So what I know now is I can just replace all these x's with 4. So I'm going to have 4 square root of 2 over 2, 4 square root of 2 over 2, and then I can just simplify this, because what is 4 divided by 2? It's just 2. So I have 2 square root of 2 and 2 square root of 2. So the missing sides are both 2 square root of 2, right? So that's just how you use the shortcut, right? We know the shortcuts, we proved the shortcuts before, and we're using the shortcuts to help us solve for missing sides. Okay, this second one, this is a 30, 60, 90 triangle, right? So I know I'm using the second triangle, and I'm going to write my little shortcuts. So I know this is x. Next to the 30 degrees is x square root of 3 over 2, and here I have 1/2 x. Here's the thing. Again, I now know what x is equal to. X is equal to 4. So what that means, right, because I have x here and I have 4 here. So I know what these x's are now. These x's have to be 4. So I can write this as 1/2 of 4. You can do it in your calculator or in your head. 1/2 of 4 is just 2. So this missing side is 2. Here, I'm just going to plug in 4. And then again, I can simplify. 4 divided by 2 is 2. So 2 square root of 3. And so this missing side is 2 square root of 3, and the bottom is 2. So it's okay if you don't totally understand how I got these shortcuts. What's important is, do you know how to use the shortcuts, okay? So if you have questions, let us know. Otherwise, move on to the practice. The practice is going to look just like these two questions.